Hello. Well, although there are many videos on this topic on YouTube, but I still wanted to create one because most of the videos that are there mainly focus on the mathematical part. But here I'm gonna show what actually happens when you use these things during your game development or 3D development or 3D animations. So what actually we are going to talk about today is the way that we observe our 3D world, that is the cameras. So while dealing with the 3D programming, developing our animations, we often use cameras to view our world, and there are main two types of cameras. So we'll see how they work, what parameters they have, and what is the significance of all of their parameters. So mostly this will be related to Three.js, and of course this will be very much similar with other 3D development tools like Unity or even Unreal Godot, anything. But this will be more relevant to Three.js developers because they are the ones who struggle with this. I'm considering that the game developers must be knowing all the crux of using cameras, but the Three.js developers, they mainly focus on the creation of the scene but ignore these very basic points that need to be kept in mind. So while I'm hovering on this camera option, you can see there are two types of cameras that we have here that we can use. So first let's start with the perspective camera because that's what we are more familiar with, and because our eyes itself are the perspective cameras, and all the cameras that we use in our daily lives like our phone camera or any other DSLR camera, those are perspective cameras. So let's have a look at them. Let me just adjust quickly the values so I can show you properly. So I'll just reduce the far value here to 50. That will be good, I guess. And I will reduce this maybe to 30, the FOV value, and we'll have a look at them one by one, what they really are. Now with the perspective camera, you get this typical pyramidical shape, and the tip or the peak of this pyramid is actually where the camera lies. So this point where we have this transform controls, that's actually where our camera is placed. And so if you are observing this screen, it means that this is where your eyes are, kind of, and the screen is this rectangle, which is also called as the near plane. Now if you notice here that this pyramid is divided into two parts. One is this with the yellowish outline, and the smaller part is with the red outline. Now this smaller part is also a pyramid, but this yellowish part is frustum. That's what the shape is. And this near plane actually has particular significance. We'll see that in a while. So what this yellow part shows us, or what does it mean here? It is also called view frustum. So what it actually means is whatever the object in your scene, if it lies in this frustum, only then it is visible to the camera, and if it doesn't, it means it won't be visible to the camera. I can show you or demonstrate to you with the example. Suppose I add a mesh here. It will be a box mesh. Currently it is at origin of the scene, 0 0 0 on all the axes, and with the standard values. Now if I try to observe it with this added perspective camera, you can see the box properly placed and no issues with that. But if I intentionally drag it to the side to make it or pass through one of the side planes of this frustum in this way, let me drag it a little inside, and now if I try to observe it with the perspective camera, you can see a part of this box is then now outside of the frame that we can observe. You cannot see the entire box in this case, and this will also happen in case we take it a little upside to make it cut both the upper and right side plane. we can see it here, whether it actually does that or not. Maybe kind of it does it. So if we again try to observe with the perspective camera, you can see here at this point, or maybe I'll dig it a little downside and move it to the left side. Now you can see this bottom left corner of the box is visible and not the entire box, because it's now outside the view frustum. I mean, the part of it is outside the view frustum, and if we take it entirely outside of the view frustum, then it won't be visible at all. So you just see the gray background in this case. Now this is okay. There's not, I mean, not a, people don't struggle with this thing usually, but the more problematic thing that people usually ignore is with the near plane. That is, most of the developers I've seen create their projects, but usually their models clip while the camera is moving, or even if the object is moving. So what actually happens in this case is, you see the near plane here. Now this is also the boundary of the view frustum. So when the object comes closer to the camera, that is even closer than the near plane, I mean it crosses the near plane to come closer to the camera at this point, even then the object is invisible, or it can also be clipped. Mostly people ignore this and also don't understand this, because they think that the object is properly in front of the camera, but still why it isn't visible when we move closer to it, and when we move away from it, it's visible. The main thing is, of course, the position of the near plane. So if you see here, if I select the camera, you can see here there are some parameters that we can adjust. Now near plane is actually the distance from the camera that we have to set. Currently it is 0.1, but we can increase or decrease it however we want. And if you see this, that we cannot have a near value for our perspective camera is 0, because if we do that, the entire camera disappears. We don't have a camera at all in that case. So you have to adjust this near value properly by considering how close is our camera going to be to any object in the scene. If it's going to be very much closer to the object, we need to set very small near value, but again we have to handle some trade-offs, because if you cannot have very small near value, that may cause some flickering of the scenes, flickering of the 3D models in your scene. So you have to adjust that properly. And again, the far plane also has same significance, that if any object goes beyond this far plane, it won't be visible. But as far as perspective camera is concerned, the typical small objects, when they are taken far away from the camera, they already start shrinking and then disappear at certain point. So if I try to reduce it, you can see it's shrinking, and at some point it will already disappear, even though it does not crosses the far plane. But the larger objects like mountains or something like that in the scene, those need to be culled with the view frustum. Now I use the word cull. That means clipping out or cutting out all the mesh or the 3D objects, parts of the 3D objects, if not the whole object, when it is outside the view frustum. That's the way of optimization. There is a very good video from Simon Dale on this topic, and I will put the link in the description about frustum culling and how games handle this thing. Now, as you know, I'm observing with this added perspective camera, and I want to show you how the near plane actually works and what is its significance. Now here is the position, or all these parameters are for this player model, and if I try to increase or maybe decrease the z coordinates value, z position of this object, I should be increasing, so you can see it's coming, or maybe I'll take it a little to the downside, and if I'm just taking it closer to the camera, like this. And you'll see once it starts crossing the near plane, it starts clipping, and you'll be able to see the inside parts of this 3D model. Like so. So this is what's happening here. You're being able to see the inside. And this is the good case because it happens when the model is very close to the camera, but in some cases you can have a large, here you can see the near value is 0.04, which is a good small value, but in case you have a larger values like 0.2, let's give it to 0.2. and now if you try to take it a little closer to the camera, you'll see it starts clipping way early than it seems to be touching the camera, like this. So this, if we try to observe it with our default camera, you'll see that this part is actually passing through the near plane, and it has passed the near plane and it's closer to the camera than the near plane. Near plane must be lying somewhere over here. So this is what happens. One more thing about the perspective camera is the field of vision, which we don't see in case of orthographic camera. The field of vision is actually the angle between this upper plane and the lower plane. So this angle is actually the field of view or field of vision. So if I increase it, the angle increases, and if I decrease it, the angle decreases. It also maintains the aspect ratio of this view frustum or the near and far plane. So even if you try to observe it from this angle, you'll see basically both angles are changing because it adjusts aspect ratio. And let's see how the FOV value affects our observation or the way we see the world. I'm now viewing from the added perspective camera, and now if I select that and change the FOV value, now it's at this point it's 39. If I reduce it, you'll see the objects, this object, if I reduce it, you'll see the object seem to be zoomed in. The object is getting larger and larger, and if I increase, the object looks smaller. Now let's see what actually happens from our default camera's view. When I decrease this FOV value, the view frustum is shrinking and it focuses more and more on the 3D model that's at the center of the near and far planes, or which is just in front of the camera. And when we increase the FOV value, it enlarges and can see other things. I can show you with some other example, like if I drag it here, if it is at the right place. I hope it is. So if now in this case you can see we have a cube and this player, and we can see the cube because we have a good FOV value. But if I try to reduce it and go on reducing, at some point you'll see the cube disappears and even the legs of the player model, and the player model seems to be zoomed in. And this is what is happening. The view frustum is shrunk down, and now the cube lies outside of this view frustum, also the legs, and only we are able to see the upper part of the player. This is what basically happens, or this is what the role of field of vision is. Field of vision is basically how much of the world you'll be able to see with your camera. So if you know, cows or buffaloes have a wider field of vision than us humans. That's what the field of vision is. Now let's have a look, or let's see what orthographic cameras are, and they are really very different from the perspective cameras. Let me just delete this perspective camera and add an orthographic camera. Let me just change the far value and adjust its position like so. Now for orthographic camera, you see there is no pyramidical shape or not even a frustum. Frustum is basically the generic shape, and here the cube or the cuboid you see is actually the specific type of frustum. So in this case we get the cuboid. And again, for the cuboid we have this near plane, this far plane, and this all these values left, right, top, bottom are the distance from the line, I mean the line that just passes through the camera from the center. So if I just try to increase the top value, this goes up the upper plane. If I try to increase bottom value, the bottom plane tries to come up. If I reduce it, it goes down. It's just a distance from the camera. And we can also change the left and right values in the code. Not here, I don't know why. Now let's set them to the default values. Okay. And again, if any object is inside this view frustum, which is cuboid in this case, only then it will be visible, and if it's not, it won't be visible. If it's closer than this near plane, it won't be visible. If it's further from that far plane over there, it won't be visible. And you see there is no field of view parameter here because we don't have any kind of angle here. It's just a simple cuboid which doesn't need to be adjusted. I mean, its angle doesn't have to be adjusted by us. It's just going to be a cuboid. That's what orthographic camera is. Now the main difference between orthographic camera and perspective camera is, with the perspective camera, the objects that are at a greater distance than some other object, it will seem smaller than that which is closer. Or I can show you with the example. I showed you before, when I was taking the cube farther and farther away from the perspective camera, it was shrinking down. It was getting smaller and smaller, but when we do that, oh sorry, let me take it in the view frustum, this cube. Hope it is. Let's see. Yeah, now it is. Now you see this cube here. I'll select that cube or the box. Now if I take this box maybe towards the camera or maybe away from the camera, anywhere, nothing, I mean the size does not change. So with the orthographic camera, irrespective of the distance from the camera, the size won't change. That's what the orthographic camera is. And we can observe it with some other example also. If I take our player model a little to the center and now observe with the orthographic camera, I select the orthographic camera here. I try to change the position of the orthographic camera here, the Z position. If I increase it, let's see, if I increase it, it goes away from the objects. If I decrease it, it goes closer to the objects. Now you'll see here, if I increase it, it goes away from the object, but still the object is of same size. If you reduce it, it goes closer to the object. Now you observe here, even though we don't see any change in the object, but at this particular point here, you see the near plane has passed the object, and then you see the clipping with this player model. And we can see from our other camera that the near plane here is cutting this player model. Now one more thing with orthographic camera is, with the orthographic camera, you see if I just take it a little backside here, you see there is some distance between the near plane and the camera's position, which is this near distance. But with the orthographic camera you can have it exact 0. Even that works, but not with the perspective camera, as I showed you before. You must be wondering how the zoom is handled with the orthographic camera, because with perspective camera it's handled by taking the camera closer or further from the object. That is, if you zoom in, the perspective camera goes closer to the object. When you zoom out, the perspective camera goes further from the object. But with the orthographic camera's case, we saw that it doesn't happen. Even the camera is very close, we see the objects are of same size, even if we take so far away from the object, the camera, still the objects are of same size. So how is the zoom handled? So with the orthographic camera's case, how it's done is, when you zoom in, keeping all the relative sizes same for the objects, we enlarge the entire scene, and we zoom out, the entire scene is again shrunk down. That means all the dimensions in the scene for all the objects will be increased by the same factor for zooming in, and for zooming out it will be reduced by the same factor. So that's how zooming is handled in the orthographic camera. So yeah, this was what I wanted to point out, and I hope this was helpful. So yeah, thank you.